Can everybody hear me? Woo! All right. I'm just going to start now. I'm Cameron Hotchkiss. I work at Tipping Point's DV Labs. Most of my job is vulnerability research, analysis. I work with the ZDI program. And we have our blog up on dvlabs.tippingpoint.com, so we'll have updates. And all my slides and any code that I mention will be available later this weekend. So by Monday, you'll be able to pull it all down. In the past, I've written and contributed to Pedram's PyMay reverse engineering framework. Before then, a long time ago, I created Absinthe, which is a SQL injection tool. I don't do web stuff anymore. And on the side, recently I've started up a mailing list for OSX reversing. It's very niche, very small, very low traffic, but it's kind of nice, and there's some pretty smart people already on the mailing list. So if you're interested in this kind of stuff, feel free to join up. And once a month when somebody posts, you'll be able to read it. So I'm going to cover, this is basically what I'm going to be covering today. File formats to tools, disassembly patterns that aren't necessarily related to specific technologies. Briefly look at Carbon, predominantly look at Objective-C, because that's the main programming focus that Apple pushes on people. And then I've got a quick list of links, but it's just for your reference later if you pull the slides down. So applications in OSX are stored in a directory structure, commonly referred to as a bundle or packages, and Finder, the equivalent of Windows Explorer, will load up as if it's an executable itself when it's really a directory structure. But it's a self-contained directory that has the binary, various supporting files, and resources. And this is what it looks like if you were to break it out in picture form. Program.app would be the name of the program itself. The program obviously would be something of your own choosing. And everything with a square or a solid border is required. Everything with a dotted border is optional. And white is a directory. Not white is a file. So you have the contents directory, which is the only thing in program.app. It contains a package info file, an info property list file. Then there's a macOS directory, which has the binary. It's suggested that the binary name should be the same as the application directory name. It doesn't have to be, but it just commonly is. And you have the resources folder, and that's where you would have the sound files, media files, icons, and nib files. Nib files are an interface, like the GUI layout stuff for coding on OSX. There's also XIB, which is similar. Then you have optionally frameworks, plugins, shared frameworks, shared support. Info.plist, I kind of blew through that because I have this slide here explaining it. It's an XML or binary list of application properties, including like the author, the copyright date, just various stuff that's going to be loaded in to the application. It's fairly well documented by Apple. I'm not going to go through all of the fields here because it's a waste of time. But if it's in binary, there's the plutil command on OSX. A lot of the commands that I'm saying are stock. Some of them may be included with Xcode. If you're going to be reverse engineering on OSX, I'm going to assume you have Xcode installed. And if you weren't planning on it, just do it. It takes like 15 minutes. plutil will convert between the binary and the XML format. And I just added that thing from the man page to. It's interesting with some of the Apple stuff because they just put random crap in their man files. So the other file that is in application bundles is the package info file. Apple doesn't seem to be sure if it's required or not because in some docs it is and in some docs it says it's optional. Generally it's there, and generally there's nothing really important that's not covered in the property list. But you're going to get APPPL, which is the application bundle tag, 4 bytes of that, and then 4 bytes of the signature. So they say for like the text editor, it's TTXT. But most of that, like I said, is going to be in the property list file. So the actual binary is going to be a Mach-O binary format. That's the standard binary format on OSX. It's got the magic number feed face. Unless it's 64-bit, then it's feed face. And you also have FAT or universal binaries, which is the code for PowerPC, which is what Apple's were running up until the past year or two ago. And it's going to have the Intel stuff, which is all of the modern laptops, desktops. And the FAT binaries have the Cafe Babe magic number. So you might be like, hey, I've seen that before, Java, or Java, depending on where you're from. Yeah, it is the same. The main thing is that Next actually predated Java, so they can pull it off, and that's where it came from. The other interesting thing, if you get into reversing on OS X, you're going to Google for Maca occasionally, which comes out as macho, and just random crap. So expect some interesting search results. I don't even know what I read that, looked at that paper. I still don't know what it was about. I think it was like auto-generated. So the Maca file format's fairly well documented by Apple, and it was fairly well documented by Next, who created it, and it's been documented by GNU. So I'm just going to quickly go through these. This is a text segment for the Maca binary. Anything with an asterisk in this chart was documented by Next at one point and is no longer being documented by Apple. So it was probably deprecated and removed at some point, but for completeness, I'm just including it in case you're looking at really, really old binaries, like the original copy of Doom. So it's pretty straightforward. There's some C++ stuff in there. The 8-byte literals you're going to see all the time. The C strings you're going to see all the time. And the text, obviously, you're going to see all the time. The interesting thing is that text is not the only place where code is going to be. There's coalesced text sections as well. IDA will pick it up, so just aim for the blue, and you're good. Then you've got the data segment, standard data segment. I'm not going to waste a lot of time with this. Then you've got the Objective-C segment. This is where all the Objective-C metadata is stored, and in the Next in Apple Guides, you get this statement, which basically says, we're not going to document it, so good luck, figure it out. Luckily, it's fairly well named, so like class references, CLS refs, it's pretty straightforward, and the format doesn't take too long to figure it out on its own. And 3 people at least have written IDA scripts to clean it up, so you don't have to spend a lot of time working on it unless you just want to figure it out for the sake of a boring Sunday afternoon. Just because I didn't have anywhere else in my slides to put this, I'm going to mention VMMap. It's a kind of interesting tool Tiller pointed out this morning for me to take a look at. It's just basically a memory map for any process that's running, and it'll give you permissions on whether you can read and write to specific segments. And instead of loading up a binary in a debugger and trying to figure out which address got mapped where, it's just a quick way to load that up. You can just man VMMap or Google it. So right now, I guess we're in the tools section of my slides. First thing you're going to need when you're reversing on OS X is a Hex Editor. Hexfiend's pretty cool. It's open source, and the code is very well documented, so you can just go add random crap to it. But it's a text editor, so I'm not going to waste a lot of time on that either. But you can grab it from ridiculousfish.com. OXEd is another Hex editor. It's not open source, but it's free, and there's a plugin architecture for it, so you can add plugins for representing all the different data types down here at the bottom. Hopefully that's clear. OTool, stock install on OS X, and it's the equivalent to object dump. If you just do -OTV, that's going to give you a disassembly straight on the command line. It's a disassembly. You can also do -L to list all the required libraries. There's a whole bunch of different flags for it. Just makes your life easier if you're stuck on the command line and you don't have any other tools available. And a lot of people have built on it. OTX is one of those tools. It will basically run OTool for you and then add symbols. I've put the symbols in blue so that they're a bit easier to read or identify. And it just basically cleans up the code so you can see where the Objective-C statements are in the actual dump from OTool. Class dump, it's similar to parts of OTools, but the difference is that it won't dump code, it'll just dump the headers. So I think those flags are wrong. But this is an example of it. It's dumping the straight Objective-C source code. So if you just want to see the the data types, the signatures, then it'll be right there. IDA. Ilfak spoke earlier. If you still don't know what IDA is, that's kind of scary. IDA Pro on OS X runs great on Parallels. I use it all the time. There's no speed issues. There's a Mac OS X version for the console as well if you want to do batch mode. They're both commercial products, but they're both worth the money, so for sure grab those if you don't already have them. And then debuggers. There's a couple scripting debuggers available. Charlie made some additions to PyDebug, part of the PyMA framework, so that it runs on OS X. Stock installs come with GDB. That's with Xcode, which comes on your install disks. PyGDB is available on Google Code. vtrace can work on OS X. Western and Beauchamp are going to be releasing redebug soon, or redebug. So you've got scripted debuggers and GDB-based debuggers. And I'm not going to spend a lot of time on this because it's being presented in 2 days. So just figured I'd give it a shout out. So calling conventions, standard call for most binaries, everyone I've looked at. And the main difference coming from a Windows perspective is that instead of pushing the arguments onto the stack, that it's going to pre-allocate the stack space and just move into the pre-allocated stack variables. You can write scripts to automatically rename these to sensible names like argument 1, argument 2, selector recipient. The one thing you're going to watch out for is the stack delta. Sometimes it changes midway through a program, so if you're just automatically looking at the frame and renaming those variables, you'll get bitten. So it's better to just rename them as you see them. Also, there's local addressing for position-independent code. I refer to it as an anchor point. In functions, they'll use it for jump table referencing. They'll use it for data referencing. And so sometimes IDA will get a little bit confused as to what that is, but I've written a couple scripts to just automatically find the anchor point or table of contents, whatever you want to call it. And it's fairly simplistic, but that it's going to be in the EBX register for the most part. And this is how they generate it. It's going to be early on in a function, a call to this function, which is 2 instructions, just returning the program counter. Or you'll have it directly inlined, which is familiar for if you've looked at any shellcode that's doing something similar to this. So here's an example of the anchor inlined at the top of you can see the call +5 pop EBX. And it's not actually being used in this example, but it's there. So they're probably going to do something with it later. Actually, that is used in this example. I totally just lied to you. Right underneath where they make the anchor, they have a reference to it, and then I've added comments. You can see at the NS auto release pool is the reference after it's been deref twice. So Carbon is the 32-bit framework for interacting with the OS X system libraries. It was a descendant of the Mac Toolbox, the original Mac framework stuff, but Apple's sort of been downplaying it recently, encouraging people to use Cocoa or Objective-C as much as possible. But C programmers and people porting applications over from Windows that want to do it quickly tend to use Cocoa and C-based applications. Interesting thing is if you can tell if it's a Windows port simply by searching for HWND, which makes no sense on a Mac program, but is all over Windows code, and they will copy the names over. HI and CG are common prefixes to libraries that are written in Carbon. But the bulk of stuff that's made and people talk about when they're talking about coding on OS X isn't done in Objective-C, which is It was created in the 80s by Stepstone and then Next licensed it out. It's object-oriented, inspired by Smalltalk, but it's just a small extra little bit on top of C. There's not a whole lot to learn other than the initial calling and defining of the methods, and then it's pretty straightforward. But the biggest change from a reverse engineering standpoint is that functions aren't called. And if you looked at Objective-C, it looks like C, where it's like you've got functions all over the place, but it's a message sending architecture. And so all of a sudden, all of your code cross-references get mangled, or they're all direct calls to object message send. So you've got all of your cross-references merging on one spot and never coming back. You can get around that, though. But so that's the biggest thing for looking at Objective-C in a binary. Unicode strings are standard, but they actually store most strings in the C string section. So it's a 2-byte Unicode string in the programming from the developer standpoint, but it's actually just stored as a null-terminated byte string. And libraries referred to as frameworks interchangeably. For the frameworks section, you have a large set of frameworks to call from. NS and CF are commonly prepended to the frameworks, Next Step and Core Foundation, respectively. It's 2 letters tends to be a common prefix for most Apple stuff. And there's a toll-free bridge, is what they call it, that NS and CF can be treated back and forth as similar objects. And as I mentioned earlier, the API is called Cocoa if you're coming from the Objective-C perspective. AppKit is a collection of the frameworks that are around GUI designing stuff. There's other stuff that's not necessarily GUI related, but that's the bulk of it. The iPhone doesn't use AppKit, so you're not going to see any AppKit code there. You're going to see UIKit. So AppKit's NS, UIKit's UI. So this is actually Objective-C. This is what it looks like. It looks fairly straightforward. The only main difference is that you have these, I don't know if the red comes out well, but the square brackets, they're selector decorators telling the compiler that it's Objective-C code. And the object that you're talking about is referred to as a recipient. The names of the arguments, which are always put in proper order, included in it, they're referred to as the selector. So I've been throwing these words around. This is what I'm actually talking about when I say that. And the arguments, if you hadn't guessed that. And that's the Objective-C method calls. So what that really comes down to be is a wrapper. It gets translated into a C function call to this message send function. You can see the recipient, the selector is concatenated as a single string, and the arguments are just attached at the end with an ellipsis. You have different types of message send calls. There's the superclass one. There's the floating point return one. This one, we'll go back. ID actually is object pointer. That's what it means in Objective-C. That's one of the small other things that it changed. But if it's a floating point, obviously it can return floating point numbers. And the main difference is that if it's a structure, there's no return value. It's passed in through the arguments, and that's modified. And that's usually when you'll see your stack deltas changing mid-function. So and then superstrat is pretty straightforward. So this is what the message send call looks like when it's in assembly. Like I said earlier, you can see that the arguments are being moved in to var 38 and var 30, which is just going to be actually ESP and ESP minus 4. Plus 4, I don't know. So those are 2 message send calls. You can easily write scripts to clean it up and just dereference everything you possibly can into strings. And all of this information is available if you just hover over it in IDA, but if you want to just make it so it's automatically all there, I've got a couple scripts to do that. And then it's really easy to pull out the actual Objective-C function calls and what's going on. Now, when I showed you the Objective-C section, this is one of those sections, a snippet from it. This is the instance methods for a download delegate class. I've cleaned this up a a little bit. Normally it's just the structure there, but I've propagated some of the names. So you can see the first thing is the actual string, which is in blue immediately after it. Then you have this offset to what looks like gibberish, and then you have an offset to the actual function that it's talking about. That gibberish stuff after it is a type encoding. And what that does is it tells the return value type. It gives you the type for every single argument, the structure, the signature of the function. And you can use this to propagate more information to your functions when you're trying to just clean them up. So here's an example from the previous page. First thing is going to be your return value, which is void. And the fact that you have an object being passed in is telling you that it's going to be an instance method, which is what the dash represents. If it's a plus, it's a class method in Objective-C. Then your colon there is going to indicate that it's a selector. There's actually two of them, but I didn't figure out how to make LaTeX show it up properly. So, and then you have another @ symbol, which is another object. ID is just sort of an overarching object pointer. It could be specific, but it's only ever going to store it as an ID. And then you have your second object there, so that's the second part of the selector. And so the stack offsets are indicated. That's what the 0, 4, 8, 12, and 16 are used for. And so that tells you the order of where everything's showing up. And you can, if it's not implicitly defined, you can figure out the sizes of the variables, but most of them are going to be implicitly defined anyways. The return value says it's at the stack offset 16, but it's, for the most part, going to come in through EAX. Unless it's one of the structures, then it's going to come in through the value being passed in. So the only reason I can think that they used the 16 is to give you the size of the last argument. So memory management in Objective-C is a little different than C. You can still use all the C constructs, but you also have the alloc call and the init call. Well, the init's not really memory management, but they usually come one right after another. So that's how you allocate something. Copy is also used to allocate memory. Both of those indicate that something is being added in. Then release, the way Objective-C handles memory management is that it is a reference counting language, so a reference counting runtime. So what release does is remove that reference that was created at some point, and once it hits 0, it's deallocated. If you get something passed in from another function and you want to keep it, or if you don't want it to, like, if you want to just add another reference, you just hit the retain, call that, and it's just ups the references by 1, so that it won't automatically get cleared out by some extra auto-release stuff, which is right here. This auto-release pool, you're going to see a lot of this, and the way it works is that it manages all of the references for objects that are being passed in from child calls, so they can get cleaned up properly, even though they've gone out of the scope of their creating function. Generally, these are going to be at the top of you're going to have the declaration at the top of a function and the pool release call right at the bottom of a function, but it's also used in loops. So at the top of certain loops that have a lot of calls in them, you're going to have another call to the release pool, or in auto-release declaration, and then at the end of the loop, you'll have, or any place where it'll exit the loop, you'll have this pool release. So you can use that in assembly to figure out where the loops are actually structured. Garbage collection was added with Leopard, the latest release of OS X, in November. Classes that have it are going to have a finalized selector. If you see collective exhaustively or collective needed, that's probably going to be calls to the garbage collector forcing it to run. The big thing with garbage collection is that it's not on the iPhone, because it takes up too much memory, and the iPhone has a smaller memory footprint. There's a bunch of stuff that didn't make it into the iPhone, so you're probably not going to see much garbage collection there, but for regular desktop stuff, it automatically will clean up a lot of people's stupid mistakes. Categories are kind of interesting as well. It's a construct for Objective-C which allows you to either override or add methods to a class that you didn't create. So you don't have to have the source code. You don't have to have permission to do it. You can just sort of stick it on and force things to do things they weren't actually intended to do. You could override the default like NS string so that whenever somebody calls length, it's going to add 7 for some reason because you think it's hilarious or whatever. But the interesting thing about categories is that all of a sudden assumptions that you might be making about certain methods that are being called for framework classes, if there's a category in the binary, then it's going to have a different behavior. So oddly, a lot of people who, when they first look at the Objective-C sections, they'll look at the category ones and just propagate the names. You should always try to keep in mind that it's going to be a category, so that way you don't make any assumption as to, if you see NS string length, but it's been overridden, you have like NS string cat length, and then you'll know, okay, there's something different going on there, and I'm not going to just assume that it's returning. Another extra thing to point out is timers. We're all familiar with timers. You have a neg screen that comes up every so often. You can use standard C stuff for doing it, but there's also 2 things in Objective-C. NS timer, which is the older timer object that will wake up every so often, and NS operation queue. NS operation queue was added in 10.5 as well, and it's suggested for multi-threading, especially when you want it to happen repeatedly. And a lot of those will be used on neg screens. And I talk a lot faster than I thought I did. Wow. Because we're already in the references section. Okay, well, a lot of OSX reversing stuff was done by Nemo. He isn't doing a lot of OSX reversing anymore, but he still has all of his papers and presentations available on his website. Also, It's Me and File Offset both wrote stuff for IDA that will propagate a lot of that metadata into the functions that I was talking about. It's Me wrote it in IDC, and File Offset took a really cool approach by taking the OTX output and writing a Lua script that will create IDC, and you can automatically run just adding the decorations into it that way. And these are some extra links that were suggested by the XSO mailing list, if anybody's interested in getting into this kind of stuff. And coming soon also is Dino and Charlie wrote a book, or are writing a book on OSX hacking, and that'll include some interesting stuff as well. They've got a couple tools that they'll be releasing once this comes out, so I figured I'd give them big ups for their book. And apparently if you pre-order now, you can save $13.50. That's 27% off the list price. So since I spoke fast, you guys got a lot of time for questions. Does anybody have any, or are we just going to go to the party? You know. Absolutely. I'm not going to change my resolution, though. Okay, we're just going into the iChat folder here. So I don't know if you can read that, but trust me, you want it this small. It's like the /applications and the iChat.app folder, and then it's contents macOS iChat. And I went one too far. Okay. Class dump. So that went pretty fast, but it's kind of fooling you because if you go through and do it through less, you're going to be hitting space for a very long time because it just keeps going and going and going and going. So this is what Dina was talking about. When I had that screenshot of the class dump, that took me about 25 minutes to find a nice little one that would fit in and make sense in the slides because it's just, and it's propagated from everything. So anything that this possibly calls is going to be coming through this. And here's actually IDA running in parallels, if you're curious about it. This is, I wrote a script as well to clean up stuff. And this is what I was talking about with renaming the variables. I just refer to them as the recipient and selector, and they're just named on a per case basis instead of just at the top of the function. But I've added comments here that dereferences everything. I always use A, but it doesn't really mean anything. It's just a placeholder variable, so I know what's going on, because it's going to come in through EAX. And I think I had something else. Here's basically a list of, this is my sort of toolbox for item manipulation Objective-C binaries, which I will upload to the DV Labs server tonight. It's by no means complete. It's sort of a work in progress, but as I just come up with silly little IDA-Python stuff, I just add it into there. So there's even sections of it that are totally commented out where I'm like, I was totally wrong when I was doing this, but I just sort of keep it as a track record of what I was doing. So anybody else? Questions? To be honest, I haven't really looked at much PowerPC stuff. Dino, have you? The question was, are there any noticeable differences between PowerPC and Intel-based Objective-C? All right. Anybody else? Bueller? All right. Well, see you guys later tonight.